So we are going to see in this video how we apply a step force to a single degree of freedom system, a mass with a spring, and then we will gauge the response of the system. So I assembled this for you before, and then this is my CAE file where there is a model mass step force. So I created the part with called mass, and then with the engineering feature of inertia of 1 kilo. Okay, we always deal here with SI units. And then the mass is here. And then on this part menu, which is the first on the top of the menu of Abaqus, is already visited by us today. And we can skip property and we go straight to assembly. Okay, in assembly, we we use the mass to instance the mass, and also in tools we created the reference point RP1 to be the one which we are going to connect the mass, the spring between RP1 and RP. This spring is within assembly, its engineering features, and then it's here with a spring stiffness of 40 and a dash spot coefficient, which is the ratio between force and velocity of, say, 2. Okay, so assembly then is done. That means we did assembly. We can go to step now. On step, we created two steps. One on the first 1 second are dynamic explicit with the nonlinear geometry on, which is when we applied the time we applied a forced response. And on step 2, we just let the system go during 3 seconds to vibrate as it wants. So then that's the response after the force being applied. So we can dismiss here. So step is done. The load, we have two cases. First, the boundary condition, which is the one where we fixed the RP1, and this is propagated through the two steps, step 1 and step 2. Okay, dismiss. And then as for load, we have a load that was created on step 1 and deactivated on step 2 for us to see the mass to freely move after being hit by this force. As for the value of load 1, we can see here, we go here on the lateral menu, and then we see load here of 1 Newton applied according to amplitude 2 on this step here. Okay, it's in y direction, because then that's why we have 0 for x direction. And this amplitude 2 we can visit also on the menu here. Amplitude 2 could be any other name. It's a step time which started at 0 with amplitude 0, and at point 1 we have amplitude 1. So then we are setting the way we wanted this amplitude to be multiplied by the value of force, and then we have the input in our system. So load, it's okay. Mesh we don't need, and then I think we can jump to job. Okay, and in the job menu, we have this mass step force model, the one we are working now. It was already completed because I ran the result before. I can see now the results. I can add the little mass here that's not shown by these plots, so I can go on view, ODB display options, then entity display. I can click here, show inertia elements, apply And then we see I can increase a little bit the size to become a bit more realistic to what we have in our minds, a mass and a spring and a damper. I can press here to see it laterally, okay. And I can now play and then see what happens, okay. And dumping takes effect here, and then of course we can create a graph to show from the field output continue. We can go to unique nodal, get the displacement, which could get velocity or acceleration in y direction from the mass here, which is the node set, and then we can plot. And then we see here the application of the load, and then the system moves, dumping, decreasing the amplitude as time passes by. Okay, thank you for watching us, and until the next video.